Okay, so static attributes, constant attributes, copy constructor, overloading operators. And I was saying that we talked about overloading 2 or 3 courses ago, which means you can define multiple methods with the same name, but with different arguments list. And you have seen that every week we overload the constructors. For example, we have multiple constructors with different arguments list. Okay, so overloading operators. And here I will give you a generic description on how you actually learn them, not memorizing them. How do you find a way to actually deduce or implement them without actually memorizing them? And we will start with equals operator. So equals operator. Okay, and others. And the next week we finish the discussion on operators. Okay, so let's take a class. And in order to understand why we need the copy constructor, again, we need the dynamic field. So I will take a class and I will focus on that. So here I will say include a string. Okay, and again, I will use the shortcut with namespace standard. Okay, namespace standard. Okay, so let's get the student back again, student, and I will minimize the attributes to the name. So we will have a name. And for the dynamic field, I want to store the grades. Okay, so these are the grades of the student. And here are the number of courses, okay, because you get a grade for each course. And these two are related. You can say number of grades, but in the end, they are related. Okay. Remember, every time you define attributes, don't forget to set some default values. And especially for pointers, null pointer, because in that way you can check them later. And here number of course is 0. Okay, so here, let's say we will validate different stuff. For example, let's create here a variable just for age, just to validate it here. And we have seen last week that we can define variables inside the class, inside the student class, which are not part of the student object, and they are kind of global. So actually static variables, they are actually managed like global variables, but they are not global because we can have static variables defined only in classes. So we are in the object-oriented philosophy, okay? So here let's define a set method for age, because in that way we need to validate the received age. So here I will say void set age. Here is the new value, the value that I receive. Okay, and we know we need to validate. So for example, here we can say the value should be the minimum age that the university may accept a student. I don't know, 10 years, 11 years. If the child is a genius, okay, and they can accept it. Or let's say the maximum age should be, I don't know, 90 or 100, whatever. So here, normally you will say if value greater than, let's say 14, and value, and let's say greater or equal, because, okay, greater or equal, and value less or equal than 90, it's okay. So in this case, I will say, I have a bracket here, sorry. Okay, so in this case, I will say this age equals value. Else, okay, else I will throw an exception, throw exception, and here I will say a wrong value for age. Okay, and we are using these predefined values. And remember, I said to you that these are called magic numbers because they can represent anything. And we know now that 14 is the minimum age and 90 is the maximum age, but maybe another person which is not present here, when it will see this for the first time, it will have no idea why 14 and why 90, or even us, we may forget that. So in order to manage these magic numbers, one approach is to use those static variables. So this is one way to use them. So here I will say static int, and because static variables, remember, are special in the way that they are not part of a student object, okay, they are like global variables in the student class. We can imagine them like this. The naming convention is to use cups. So here I will say mean age, okay, and here I will say static int max age. Okay, and in this way, instead of writing 14 and 90, here I can say mean age. Now I can use this statics directly, okay, if you remember from last week, but I said to you that I will always use the official way of naming them, which involves the class name. And we have seen this syntax before, for example, for namespace standard, okay? So if I remove the using namespace standard, every time we are using cout, cin, end line, we need to use this syntax again, which requires the namespace name before those variables. Now, for statics, the official way to use them is to use the class name specifier, which is this one with the 2 points, and after that, the static. But again, you can write them directly, and it's your choice. So I will not make you write them like me or only like this. You can choose. For me, there are many advantages of using this approach because I can, if we have multiple classes in our project, I can see which is the source of this static when I see the class name, for example. So this is an advantage because I can have different classes. For example, we will have another class called professor, and professor will have also mean age or max age and so on, retirement age or something like this. So in that way, I can distinguish between them. So that's why I will always write this. And maybe this will also help you see that this is a static. Again, we use cups because they are special. And when I say they are not part of a student object, I refer to this. So if I will draw the memory of a student object, they look like this, okay? So they will have these attributes: name, they will have age, they will have this pointer called grades, and they will have number of courses, okay? So here you just add the size of this variable. For a string, we don't know precisely what's the size because string it's another class. So let's ignore the string object because it's another object. Depends on how C++ is managing that. But for all the others, we can say age is 4, this pointer is 4, number of courses is 4. So we know the size of a student is 16 plus this X here, which is the size of the string object. Okay, we can check it with size of, for example, if we want to see it, but that's not relevant. Now, if I remove the static, so if you remove the static keyword from here, now in this class, you will also have these two variables in this object, sorry. You will have mean age and a max age. So all your objects, every time you create a new student will have the same data, will have the same variables, which means this here, the name, age, okay? So you have these variables here and also these attributes without the static. So if you have 1 million students, you will have 1 million variables, mean age and max age in each student, which is, I don't know, it's not efficient. Why is not efficient? Because you will occupy a lot of space by storing the same values again and again, because I presume mean age and max age are the same. And you'll have another issue if you want to change mean age and max age, because you need to go through all your objects and say, hey, remember, you have a mean age and max age, which you normally don't use, but the software is using. These are the new values. So that's why when you try to define an attribute or a variable in a class, and you don't want to make that part of your object, so you don't want to store this here, you maybe want to store it here in a special space, whatever, and you want to store those two variables here only once, because why storing them many times? So they will be, they will have no relation with the objects. So if you want to have this, then go for static. So with static, all these variables are here. They are stored in a separate memory area, separate from your objects. So you will not have mean and max age here. In your objects, you'll have only these attributes, the non-static ones, and these two variables will exist only here, only once. okay? And this is the most efficient way. So if you want to change them, you just go here and change them, and the objects will have no relation with these statics. So one way to use statics, you see, is to store predefined values. Now, remember from last week, they have this very strange way, and this is the C++ way to initialize them. So you need to go outside of your class. This is where the class terminates. And here I need to write student max age equals, let's say, 90. And here I need to write int student mean age equals, let's say, 14. And now I will initialize them. So this is the only way init the static attributes. Okay, so this is the only way to actually initializing them. Because if you try to initialize it here, you will get the compiler error. So if you forget this, the compiler will remember you, hey, you can't do it here, okay, for this one. Okay, now let's suppose we want to store here in the student, or we want to define, because this is more related with databases. In the end, all our students' data will be stored in a database. So we know that in a database, you need to have a unique key, which is associated with your data in order to search for that fast. So for that reason, we will define here something like an ID. This is your registration number. Let's call it registration number. Okay, registration number. So you have this unique registration number, which is associated with student, and this relates with the primary key of, let's say, the students table in the database. Okay, and at this point, we know that every time we will create a student, we want to receive this registration number. And another thing that we want to do is, once you create a student, we want to, let's say, prevent anyone from changing this variable. Now, at this point, no one can change this variable. Why? Because it's private. So here, if we create a student, so let's create a student. Remember, we have the default constructor. Okay. If I try to say student dot, and you see, I don't see anything, only set age, because it's the only method public here. So if I try to say registration number equals, I don't know, 1, you'll get the is inaccessible, which means it's private. So we can't. So because of the encapsulation, no one can change this attribute. But can we change it? Yes, we can. So if I write here void change registration number, okay, and let's say I receive here a value, I can write here this registration number equals value. Okay, so by encapsulation, others cannot change directly, and now they can't even read registration number because it's private. But you see, we can. And sometimes this is dangerous, because the biggest danger to yourself is you. Here, you can do mistakes, and they are very dangerous because here you can actually access stuff that others can't. So we are the biggest danger to ourselves here inside the class, the owner of the class. So how can I prevent this happening? Remember, if we have here a char asterisk, in order to prevent it from, if we have a function which receives a char asterisk, for example, I want to define a set name. Okay, name, it's a string, but we can also receive a char asterisk, okay, value. And remember, in order to convert the char asterisk into a string, you have the string constructor like this. So it's like this name equals string of value, like this, and you just convert the char asterisk to a string. So remember, when we talked about this, I said to you, hey, watch out for changing, or don't change the input values, especially when you receive a pointer, because you can, but it makes no sense. And I recommended you, and this is the way we always write, to use a const. Because if I try to change the value here, for example, if I try to change value 0 equals x, then you get a compiler error saying expression must be a modifiable left value. So that's why we write this const here. And you have seen I always write it. So in order to prevent changing something when you can, we use const. So let's go back to registration number. Others cannot change registration number, but we can. And if this could be a danger to ourselves, because maybe the logic of the program is once you create a student, you are not allowed to change his registration number, but we can. And we can do that by mistake by writing this function here and call it. Then in order to prevent that, we can block everybody, including us, from changing this. So I will define those attributes that I will say no one will ever change them, and no one, I'm including me also, by defining them constant. Okay, so when I'm defining this constant, you see, when I try to change the registration number, we see the previous error, expression must be a modifier left value, which we accomplished the objective. Now, no one can change them. No one can change that, including us. So we are trying here to change it, but we can't right now because it's constant. So when I define a constant attribute, things are becoming a little bit more complex than before. Why? Because you see, having this constant here, now we have a compiler error here. And this is a new error. It's saying the default constructor of student cannot be referenced, which means cannot be used. And now this is like laughing in our face. It is a deleted function. So now the compiler is actually saying, hi, I'm sorry, you don't have the default constructor anymore. I have deleted it, or it has been deleted. Okay, but if I delete the const from here, the error is gone because we know that we get a constructor for free, which is the default one. So this is it, we got it. But when I define a constant, things are not like before, which means if you have at least one constant attribute in your class, you don't have the default constructor. So what's the reason? This is not a joke. This is the way of the compiler to actually tell us, hey, do you realize that here you have a constant variable which will remain forever with the default value? So this is the way of the compiler, which is trying to give us this alert by removing the default constructor. Because if we would have the default constructor, then registration number will get the default 0xCCC and will remain with that value forever. Okay, so now the compiler is saying, do you realize that? So that's why when you have a constant in your class, you don't get the default constructor. Now, if you still want the default constructor, and I think we talked and we said, maybe we will need it, but maybe us, but not others. But let's say if you still want to provide the default constructor, now you need to write it. So let's write the default constructor, student. And if I define the default constructor, you see the error is removed from here, and now the error is moved here. And we have a new message. Student, which means this constructor from the student class, does not provide initialization for const member student registration number, which means, hey, I saw you have defined the default constructor, but do you remember you have a constant attribute here and you need to initialize it? So the rule is, we have a new rule. The first rule is this one. If you have at least one constant attribute, you don't get the default constructor for free. And if you define any constructor, so this one or another one, you need to initialize the constant, because otherwise you'll have this compiler error. Okay, for example, let's define another constructor which receives only the name. Let me show you. It has the same error, string name. So if I define this one, you see I have the same error. Student constructor that receives a string provides no initializer for const member. It's explicitly saying const member registration number. So at this moment, anytime we will define a constructor, it's mandatory to initialize this. So how do we initialize it? Normally, we should try this. This registration number equals, let's say, 1. Or here, I will say another value. But when you try to do this, the error is still here. So the error has not been fixed. And now we have another error. Expression must be a modifiable left value, which says, hey, this is a constant. You can't change it. Yes, we know, because we define it constant. And now this is a very awkward moment, because we try to initialize the constant variable here in the constructor, but the constructor is saying, no, you can't. So another, let's say, strange implementation in C++, which is not natural. You can do this in Java, C#, fortunately in the second semester, and other object-oriented languages, you can do this, okay? But in C++, you can't, because when you are in the constructor, when you write code here, between these two brackets, the variable, the constant variable has already been created and it's sealed. You can't change it. And the only way to change it is to use, and we will see this for inheritance, this is called the class initialization list, which means I will open the initialization list here with, again, 2 points, but not two pairs, just one symbol. And here I will say the name of the constant attribute, registration number. And here is like calling a function, or calling the constructor. Here you need to pass that value. So for example, here, every time we will create a student with a default constructor, we set this to 0 by default. Okay. So this is one way. Now here you will say, what value do you want to pass? I don't know, maybe again 0 or 1, who knows? Or maybe we can ask the programmer. So here I will say, give me the name and also give me the registration number. So I will write this differently just to show you which one is which. So let's say ID. Okay, I will call it ID here. And now I will say, I will use that ID to initialize my registration number. Okay, and here I will say this name equals name. Okay, so you see, for a constant attribute, you have multiple choices. You can go for a default, but you need to be aware that from that moment, that value will always be 0 and you will never be able to change it. So it doesn't make any sense, this approach here. Okay, or you can set another value, not just 0. You can choose the value, or you can ask for that value. So you see here, I can ask it. So every time a student is enrolled, I will also provide an ID, and that ID will be used here. Okay, now let's write also the constructor, which also asks for the age. So string name, int ID, or I can start with int ID. I think it looks much more natural. ID, name, and age. And here, again, it's mandatory to initialize the registration number with that ID. And if you like this approach, and you see it's mandatory for constants, the next question will be, so can we use this approach also for other variables? And the answer is yes. So here I can say age. Let's name this differently. Age value. Let's call it age value. And here I can say age of age value. Okay. So if you like this approach, you can use this initialization list for any other attributes in your class. You see here, I'm using also for age. So this is not only for constant attributes. It's mandatory for constant attributes, but you can use this approach here for others. Okay, so you just write a comma and you define another one. Now, if you write here name equals name, and if you write here this age equals age value, is redundant. You already have initialized age with age value. And if you write this again, you copy it again. So this is redundant. Okay, so you either use the classic approach, is redundant. Okay, or you use the initialization list. And there is no limit here. You just add another comma and so on. For example, I can write this constructor. Let's see, what do I have here? Name, age, okay, grades. I'm not asking for grades. Okay, can I pass another one? Or I will just write it and show you. You can also use it for strings. Don't use it for char asterisk. So you can also use this for strings. So if I will rewrite this constructor, I can write it like here, name of name. And always this is your attribute. You see, this is the grade color variable, which is this one from here. So let's say name value, just to show you which one is which. So here I can say name value. And you can use this also for strings, but don't use it for pointers. Okay, don't use this approach because it will do shallow copy. So right now, you don't need to write anything here because you initialize your registration number with the ID from here. You initialize your age using the age value from here, and you initialize your name using the name value from here. So in this way, you don't need to write anything there in the constructor body. If you check different tutorials over the internet or tutorials or courses, you will see that many times they use this approach because it's faster. Okay, you don't need to write this again. So you can use this for any type. So let me give you a hint here. Don't use, don't use the initialization list, the constructor initialization list for pointers. Okay, it will do shallow copy. And we have covered shallow copy last week. It will do shallow copy, which means we'll copy the address from that pointer to your attribute. It will do shallow copy. So for pointers, if you want to do deep copy, you need to do it manually, create a new array, and so on and so on. Teacher, okay, yeah.
Do we still need the accolades for this?
Here?
Yeah.
Yeah, because remember, this is the body of the constructor. So if I define just the header without a body, that's not implementing the function, it's just defining the function. So here we actually want to implement it. So yeah, the brackets are mandatory. Okay, even if you don't need to write anything here. Now here, we will have a compiler error because you see we have two constructors with the same arguments. Let me show you. So if I try to create here Alice, student Alice with ID 1, name Alice, and age 21, we will have a compiler error. Let's see, build. It's saying anything? Yeah, you see, member function already defined or declared, the one with int, string, int. So based on overloading, if you want to keep both constructors, you need to change the order. So for example, let's make this one name, ID, and the age, because this will be string int int, which is different from int string int. So now the compiler can see the difference. Okay, so having a constant attribute, you don't get the constructor by default, and you need to write the constructors, including the default one if you still want that one, and it's your job. It's mandatory to initialize the constant, and the only way to do it is using the class initialization list. Okay, this is the name for this approach. And once you see this, you can use the initialization list for others, and I will mix them. So starting today, I will mix them from time to time, just to show you and to keep you up to date. Okay, now, how can I initialize the constant? You see, the easiest way to initialize a constant is either to choose a default value, and you just use that default value. And some of you will say, yeah, but this is not a magic number. Yes, it's a magic number. So how can I remove this magic number? I can define here a static int default ID, default registration number. And again here, some of you will say, so let's initialize it here. Int student default registration number equals 0. So instead of writing 0, now I can write default registration number. So I can use a static for that. Okay. And some of you will say, yeah, but now someone can change the default registration number. So let's combine a static with a const. So here I will say const. Okay. So right now, the default registration number, it's also static and constant, which means no one can change this, including us. And you see that for statics, initializing the static variable, is not working as before. So declaration is incompatible with const int. So let's add here a const also. You need to provide the same. You have seen the error. It's actually saying this. Hey, in your class, you have defined the static with const int, and here it's only int. So you need to match them. Okay. So build, rebuild. Okay. And now I have a static and a constant. At this point, I think max age and min age could also be made constants. And instead of writing here 0, I can write student default registration number. Okay. So right now I have removed the magic number. So I can use a static in order to get a value for my constant attribute. Okay. Now, if I can use a static, why not using a counter? So why bothering of choosing the ID? So why choosing the ID and not let's generate it? Remember, if you play with databases, when you define a primary key, in many cases, the primary key is incremented automatically. So the first record will have 1, 2, 3, and 4. So in order to use a counter, so I need a variable in my class which will be increased each time we create a new object. So again, I think a static will be perfect for that. So I will define here a static int, and let's say student counter. Okay. And initially the student counter will start at 0. And every time we create a student, I will increment the static. So we have seen now that we can use statics to update different values in our software. For example, to know how many objects we have created. So let's increment the student counter. So where do I increment it? In my constructors. For example, here registration number, I will say student counter plus equals 1, and I will do this in all my constructors. So each time I will create a new student, I will increment this one here. Okay, here and here. Okay, and here. And now you see, now I have a reason to write something here. Okay, to write a student counter here. And don't forget to initialize it. So int student counter starts at 1, let's say. So the first student will have 1. So we can use the student counter for our source of the unique IDs. Why? Because this is always incremented. So every time you create a student, you will have a new value for that student, okay, for that ID. So here, this constructor, for example, so let's write this one. The constant is initialized, with the default value from a static. Okay, so here we are going for this approach. Now here, let's initialize it with a value from a static attribute. And here, instead of using 0, I will say, hey, let's take the value from the student counter. So in this way, every time we will create a student with this constructor, we will see a new value. The ID will be incremented. So each student will have a unique ID. Now here, we have initialized it with a value that we receive. So initialize with a value received. Okay, so you have here different ways of initializing your constant. So the question is, which one do you choose? And the answer is the one that will help you solve the real problem. So if you want to be sure that your students will have unique IDs, then you can use a student counter. If that's not the case, and in reality, the secretary or the operator which will enroll a student will provide the ID, then you ask for that ID, you see? So depends on how the real life is actually dictating you what the software should do. Remember, the software should map to the reality. We should solve real problems, not invent new ones, or live in a parallel world. Yeah.
But why doesn't the student counter start at 0?
We don't start at 0 because you see we increment it after we create a student. So if you call student counter here, the registration number, so let's imagine this is 0 and this is the first student we will create, right?
Yeah.
So here registration number will take which value if we start at 0? 0.
Yeah.
And after that we increment it by 1. So in that case, I always start at 1 because I want that my first student will be 1 and the next 2 and 3. Another way to write this, I remember you asked me something yesterday.
Yeah, exactly about this. Yes.
Exactly. So another way of doing this, actually to combine this line with this line, will be to write it like here. So if I write here student counter plus plus, this is actually, this version is identical with this one. Why? Plus plus means use the value and after that incremented it. So here again, the registration number will take the value from student counter, and if that's initially 0, you get 0, and after that, this is incremented. If you want to increment this before you pass the value to registration number, then you will write it like here, because this is the pre-incrementation, which means this will execute first, which will increment the student counter, and after that, it will give you the value. So here, for this case, we can start at 0 with the counter because the first student will get, this is incremented by 1, so you get 1. So you see there are 3 different ways to write that. And here we can start at 0, here we start at 1. Okay, so now it's clear why you have seen that one with plus plus here.
Yes, it makes sense.
So that's why. But if you don't like this approach, you can start at 1 and you can use the classic approach or the equivalent one with plus plus here. But if you want to start at 0, then you say plus plus before because you want to increment, and after that use that value for registration number. Okay, so in this way we can initialize our constants. Okay, so it's not mandatory to use a static. This is what we want to clarify this year. So I want this year to be the first year when we meet at the exam and you get a static or a const and you ask me, hey, how do I initialize the constant? And I will say which way you want. So you will have different possibilities, okay? Because if you check examples from your colleagues, they all use this counter, okay? But this is not mandatory. This is a choice, okay? You choose this, okay? But you can also ask for ID. It's just another variable. For example, let's introduce another one just to clarify. Let's ask for the birth year, okay? Because this is constant, right? So we all have a birth year and we can't change that, okay? So let's define it here. I will say const int birth year, okay? Not the date, just the year, okay? Just the year when the student was born. So here I will have const int birth year. Again, I have another constant, and you see all my compilers now, they have a compiler error, or all my constructors, sorry. Here it is. It's saying, hey, you don't provide an initialization for birth year. Okay, so all the constructors have an error now. So what do we choose to do here? So here you have registration number, and here I will say, okay, I don't know, birth year. I can go for another default, let's say 0 in this case. Okay, now for this one, again, birth year 0. Okay, for this one with name, again, I don't have any value here. I can't use a counter. It doesn't make any sense, right? So you use a counter, so birth year will be what? 1, 2, 3, 4. That doesn't make any sense. At least they are 0. Okay. Here I will have another birth year, 0. And the story will go on. And maybe at some point, I will create a constructor which will ask for the birth year. So let's fix these ones. And now let's write the constructor which also asks for the birth year. So let's write that constructor. So student, let's go for the one with int ID, string name, int age. Okay, and here I'll say int birth year, year. Okay, and I will use the initialization list for all of them. Okay, so I will have this registration number. Here, you don't need to use a specific order. You just need to initialize them. Okay, so here I'll say name, age. Okay, and the last one is birth year of birth year. Okay, and I can use an enter here because the line is becoming too long. And now maybe here in the constructor, I can increment it. Okay, so now you have student counter plus equals 1. And yeah, I have another one here. I forgot about this one. So also let's add here birth year. Okay, so you can use how many constant variables you like. Okay, there is no limit, but watch out, you are responsible for them. So you need to initialize them. And the only way to initialize them is to use the initialization list, which you can also use for other variables. Okay, and you have seen how to initialize constant statics. Okay, so you need to repeat the const here when you initialize the static. Okay, so this is the story with constant and statics. Okay, and let's choose to say we have multiple ways to initialize the constant. We don't need to use a counter. You can ask for the value. You can use, if that makes sense, a counter, or you can use another static. But normally, you can ask for the value. Okay. Here you see I'm asking for the registration number, and I am also asking for the birth year. So if someone wants to build, let's create John with that constructor. So this will be John. And here I should pass the ID to, this is John. Okay. Age 21 and birth year. So that will be what? 21, 2000.
Yeah.
2000. Okay. So that will be birth year for John. And if you try to change the ID, the ID or the birth year, you can't. So let me ask you something. If you have a constant attribute in your class, can you make it public? It is dangerous to make it public, a constant attribute, or we can make it public so anyone can access it. What do you think?
I think we can make it public because they cannot change it since it's constant.
Exactly. So you see, I can make the registration number public because I don't need to provide the getter. Okay. So why to provide the getter? Because they have access directly to it and they can't change it. Now, if someone will ask you to define a set method for a constant, what would you say?
I would say no.
Exactly. Okay. So you can consider that's it's a joke. Okay. So for example, let's print here. Cout end line, John ID.
I think we forgot to initialize the birth year.
I forgot to initialize it.
I think so.
Where, here or
no,
in
outside
the
the class.
Yeah,
outside the class where we.
Yeah, but the birth here is not static.
So it doesn't need initialization.
Yes, it needs, but we need to provide it here in the constructor.
Okay.
So static, let's do a resume. Static attributes must be initialized here, only statics, and constant attributes must be initialized here in the constructor using the initialization list. And if you have a static and a const, again here. So all statics are initialized here, and all constants, just constants, are initialized here using the initialization list. Okay?
Okay.
Okay, so these are the two rules. You can use the distinction between static and the const. Okay, so let's see. John ID is sorry, and let's say John dot, and I see the registration number. Now let's see to check the counter. So which constructor will initialize the ID with the counter? Yeah, this one here or any of this, but again here the compiler will give us an error because we have three constructors with the same name and the same initialization list. So you need to choose which one we want to keep, because you can't have all three. They have the same list of arguments. So let's comment these two. So they are alternatives. Let's write here alternatives. Okay, and I will have this one. So if I will create a student with that constructor, so let's create Bob. So it will be just Bob. Let's print Bob ID. So I will copy this line, and here will be Bob ID is. So let's see. Here you have the default constructor. So the counter will become 2. Another constructor 3, and here will become, so this will have 1, 2, 3. So Bob should be 4. Let's see if our logic is correct. Start without debugging.
Don't we need to write Bob.registration number?
Yeah, I just copy paste and it's still John, right? Okay, this is the danger with copy paste.
Yeah.
Okay, it's doing the same stuff. Thank you. Okay, so let's see. And now you see Bob ID is 4. Why? Because we are using that counter. So in this way, you can use that. Now, always choose which is the best solution for you. Because you see right now, we can also create Vader, which will try to impersonate Bob with the same ID. So this will be Vader trying to hack Bob account. And here Vader knows that Bob has ID 4. So it's trying to get into Bob account. And here it will say, hey, I'm Bob. So it's trying to impersonate Bob. And you see, because we have also the option to pass the ID, at this point, we can create multiple students with the same ID. If this is something you want or you need, yes, we will take a break, then it's okay. But if this is something you want to prevent, you need to choose which way you initialize your constants, either using the counter or either asking the developers to pass you the ID, okay? So always the solution depends on what you want to do, okay? Always check the reality. Go to the secretary and ask it, hey, is it allowed to create 2 students with the same ID, or how do you get the student ID? And if the secretary is saying we are writing that ID, we have a register here and we choose an ID for a student, or they say it's generated by the system, you see, you have your answer. And based on that, you know how to implement it. And sometimes you have different ways. Okay, so this is the story with statics and constants. Okay, so when do we, and let's summarize this and take a short break. So when do you need a constant attribute? When you know that no one should be able to change that. For example, these 2 attributes. When do you define a static? Okay, why Bob ID is not 3? Bob ID is not 3 because we start at 1. Okay, so you start at 1 and we increment it after we use it, you see? So we are incrementing after we are using it. So the first student here, remember, student counter starts at 1. This will get 1. This is this constructor here, this one, the default one. So you get registration number, okay, it will get 0. And you see counter plus equals 1. So after this constructor, the student counter becomes 2. Okay, so it was 1, now it's 2. Here you use 2 and after that becomes 3. Here you are using 3 and becomes 4. And when you call this, which is this constructor here, you see I'm using the counter and I'm incrementing the counter after that. And that's why it's 4. Okay, if you increment it here before, then it will be 5. But we start at 1. So this is important. We start at 1. The student counter starts at 1. If we start at 0, yeah, then Bob will be 3. But the first student will be 0. Okay. So when do you need statics? And just to finish the resume, we are using a static when we need some variables which are related with the student story, but not related with the student object. Okay, you see mean age, max age are variables that we use here in this context. Again, default registration number, student counter. So these are variables which, let's say, are used by the developers to handle different stuff regarding students, the student story. Okay, and that's why we define them static, because we don't want to store these variables in a student object. We want to store them in a separate area. So in this way, you choose which are statics and which are const. Okay. Okay, so let's switch to the copy constructor. And I want to take another class because this one is already filled with constructors, statics, const. So let's create a new story. So let's define a class for let's say gradebook. Okay, so this is the gradebook, which is storing the grades for a course, let's say. So here I will have the course name. Okay, course name, and here are the grades and the number of grades, or a number of students, because it's the same number of grades. Okay, so we have this gradebook class, and let's define a constructor which will receive that those grades, or we can add new grades to that. So I think let's add a method which will do that. So here I will define a constructor, so gradebook, which will receive the course name, and I will use the initialization list. So course name of name. Okay, so in this case, I don't need to do anything here, but as your colleague asked, these are mandatory, the brackets. Okay, and let's define a method which will add a new grade. So here I will say void add grade, and this will be the value grade. Okay, so we want to add a new element in that in this array. By default, this is null. Okay, and by default, this is 0, and by default, this is empty string. Okay, so let's add a grade. So I want to add a grade here in the grades array. So we know we discussed this in the first 2-3 weeks. If you have an array, you can't add a new element at the end of it, because you will never know if you have extra space. And the only way to actually do this and be sure it will always work is to create a new array. So let's do that. So here I will say int new array equals new int of this number of grades +1. So we create a new array with size +1, and we copy the values from the existing, because you don't want to lose the previous grades. Okay, so you just add a new one. So I at 0, I less than this number of grades, I ++, and we just copy them here into the new array equals this grades at index I. Okay, and after you copy them, don't forget to add the new grade. So this will be new array at this number of grades, because I didn't increment it. So remember in C, the index starts from 0 to n-1. So this is the newest value, which is actually n, okay, equals grade. Okay, and here I will say this number of grades plus equals 1. And now we want to keep the new array, right? So we want to keep it because we just created it. Now we have the previous grades and the additional one, and we want to keep it. And I want to keep it here in this pointer. And remember, if I write this grades equals new array, at this point, I will get the new address of the new array, which has the previous grades plus the new one, which is what I was intended to do. But now we are creating a memory leak because these grades, this pointer was pointing to the previous grades array. And now you initialize this pointer with a new address. So what will happen with the previous array? You lose it in heap. So you create a memory leak. So let's avoid the memory leak. And here I will say if this grades different than null. Someone, some of you asked me yesterday, hey, is this really necessary? Can we just go and do the delete? And the answer is yes. So you can skip the if, you can actually do this, delete these grades. Okay, so here, because now delete is also checking for null. So if this pointer is null, it will not delete it because it can't. So you can write this directly. Okay, so in this way, we avoid the memory leak. We talked about this last week. So now we have this class which is managing that dynamic array. Now let's print the grade book just to check.
Sorry, I have a question if it's possible.
Yeah.
Isn't there any way to do it another way? I mean, to not have to copy the whole array and into a new array and delete the old one?
No, there is another way in terms of we can do exactly this with less instructions. In C, you have different functions which can resize the array, but actually they do what we just did.
Okay.
I don't remember. For example, here, instead of doing this for, to copy the values, you have mem copy. Okay, so you have mem copy from C, and you just copy from this pointer into this pointer the number of bytes, which is actually the number of grades multiplied with size of int. So you can replace the for with mem copy. And I think for this and actually the entire process, let's see if the IntelliSense is helping me. Mem resize, or if someone remembers, mem copy, okay, mem move or resize. I can check it, but it's from C. Okay, but in the end, it's doing exactly the same stuff. Okay, it's trying to create a space, additional space, and copy the values there. So in this way, you do exactly what that function does, and you have full control. So yeah, I will check that, and next week I will tell you which is that function from C. Which yeah,
about line 115.
Yeah.
So we basically add the grade that we want at the last index of the new array.
Exactly, because let's take the scenario where when you have some grades, or let's cover the both cases when you have 0 grades or you have a grade. So let's see, for the case where you have 0 grades, it means that the grades array is null. So when you don't have grades, this is null, right? Number of grades is 0 when you don't have grades, and grades is null. Okay, so this will be null pointer. Okay, so in that case, let's see what will happen. You say new array equals new int this number of grades, which is 0 plus 1. So now you create an array with only one element. You copy nothing, so this for will not execute because is 0 less than 0. It will not execute. And now you say new array of this number of grades, which is 0. This is your first value, right? The first value in array, it's index 0. So it will work. Now let's check the other case when you have an array. So let's suppose we have some grades here, 4 of them. So this is the index 0, 1, 2, 3. Now in this case, number of grades will be 4. You have 4 grades, and this pointer will point here. Okay, so you create a new array size +1, which means 5 elements. So now we create another array. Okay, 4 here and +1. This is the new one here. Okay, you copy all the values from here, and now you say new array, this number of grades, this is 4. Where is 4? You see 0, 1, 2, 3. 4 is this one. Is the last one, which is the value that you want to add. Okay, so in that case you can use it. But if you, I don't know, you switch this here, that's a different story. Now it will be this. Okay, because now you incremented the number of grades, and after that you use it, so it's -1. So watch out where you increment the number of grades. Okay, because if you increment it here, there is -1, but if you increment it after that, is number of grades. So it depends where you change the value of number of grades. Okay. Okay, so let's print the grade book, because we want to see the values. So here print, and here I will say cout end line. Okay, and here I will say grades for this course name, and here I will say for int I at 0, I less than this number of grades, I plus plus, cout this grades at index I and a space. Okay, so right now we have this class, okay, which it's able to store grades. Let's test it. So I will have here gradebook. Let's see, OOP, object-oriented programming. Okay, OOP. Let's add some grades. OOP add grade. Let's add a 10, and let's another one and a 9. And now I will print it. OOP print. So if we will run this, build, rebuild. Okay, and now new share, and yeah, let's run it. And after that, debug start without debugging. Okay, and these are my grades. Grades for OOP 10, 10, 9. Okay, so it's working. We can store grades. Okay, so what's the copy constructor? Let's just add here a space or something like this. Okay, so what's the copy constructor? So the copy constructor is something we will need, and generally if you don't have it, the application will crash. Let me show you why. Now, remember that we also need to clean up the space. So here we are cleaning up the space here in add grade. And we also know that we need to add the destructor. Let me show you something interesting. So I will go here and I will define a function. So here we are in the global space, void do something. Okay, so I have this function, do something, and here I will say, hey, this function will receive a grade book. Okay, and here I'll just add the message just to show you that it's running. So cout end line, okay, something. And you see, we are not processing the grade book at all, something. Okay, and now let's call this function here, do something. So is actually doing anything? No, it's just receiving a grade book, so OOP, and it's not processing the object, it's just printing do something. So build, rebuild. Okay, now debug start without debugging. Okay, and you see do something, so it's working. It's just a generic method. and we see exit code 0. So it means everything it's okay, right? Because we don't see any reason here to worry. And now we remember that, hey, we forgot to implement the destructor. Remember, if you have at least one dynamic field, when your object is destroyed, you need to clean up the space that that object might created in heap. So we say, sorry, let's implement the destructor, class destructor. So here I know that I have the gradebook. Okay, I told you that we don't need to write if, so let's not write if. So I will just say delete grades. Okay. And now you see, I just added the destructor. Now build, rebuild, debug start without debugging. And here it is. The program crashed. So I see grades something and the program crashed. So at this point, which do you believe that is responsible? Which function from those we just wrote is responsible for the crash? So which will be the first candidate to blame?
The destructor.
The destructor, right? Because it doesn't make any sense. So if I comment the destructor and run this program, will run. You see, build, rebuild, run it. Start the debug, start without build, rebuild. I saw some errors. It's it's open. The exe is still open. Let me close it. You see, it's saying it's denied the access to the exe. You need to open, close the command prompt. So let's try again. Build, rebuild. Okay, and now debug start without debugging. Again, it's running. So obviously the destructor is the reason for that. Now, it's not the destructor. The destructor is actually just revealing the truth. So here, the destructor is just doing the job. Do something is not to be blamed, but actually the reason for the error is given by the fact that we forgot to implement another constructor, which is the copy constructor. So you see this strange behavior, and I wanted to show you because you will encounter it many times. So why is crashing? Let me draw the memory for you. So let's focus on gradebook. You see, we have the gradebook here. So right now on the main stack, so let's again draw the main stack. So this is the main stack. On the main stack, we have a gradebook object, right? So here is the gradebook object. So what do we have in this gradebook object? So this is gradebook. What data do we have here? So if you check the gradebook definition, it's not much to say. There is a string, a pointer, and number of grades. So here we have a string. We have the pointer grades and the number of grades. Okay, so this is the data encapsulated in this gradebook object, and the object is called OOP. Now, after we called add grade, and print, we know that, because this is what we did earlier, we know that in heap, we will create, so this will be heap. Let's draw heap. Okay, this is the heap. Okay, heap. We have in heap, we have an array of grades, okay, where we will have these grades, 10, 10, and 9, 10, 10, and 9. And we know that this pointer is pointing here, right? So that's the idea, to have a pointer pointing to something in heap. And this is the story that you have here, gradebook, OOP, add grade, and print. Okay. And if we comment do something, you see, I have the destructor implemented, but if I comment do something and run this again, so build, rebuild, and run it, now it will run without issues. Okay, so it's not the destructor to be blamed. So actually, you see, there is something we do something, but actually do something is not doing anything. You may say, yeah, it's not doing anything with the gradebook. Why is crashing? Because actually do something is doing something. It's asking for a gradebook object. So what do we know that will happen when you call a function? Again, you will have another stack, which is called do something. This is the do something stack. Okay, do something stack and do something. And on the do something stack, we have what? Check the input argument list. You need a gradebook. So do something in order to execute needs a gradebook object. So it will ask for this object here. And we pass the value of which object from main? Of OOP. So this is OOP. This is the object here. And you see when we call do something, we pass this object, which means we pass the value of the object, which actually means someone is copying the values from this red box into the blue box. And the blue box for do something is called gradebook. So this is the gradebook object here, gradebook. Okay, so someone is copying the values from here. Now, when you copy the name, you get what? You get the name here, right? You get the name, which is OOP. Now, when you copy the pointer grades, what do you get? Here, you get the same address. This is a pointer equals another pointer, which means now this pointer, it's pointing to the same address. When you have equals between two pointers, you copy one pointer value into another pointer value, which means you copy the address. So right now, do something has a copy of OOP object from main stack. This copy is called gradebook on the do something stack, and both objects share the same address. Now, do something is doing almost nothing. It's just printing a message, and now do something terminates. What's happening with the do something stack when it's terminating? The stack is destroyed. What do you have on the do something stack? You have an object, gradebook, which function will delete this object gradebook from the do something stack? The destructor. Remember, every time an object is destroyed, the destructor is executed. So what does this destructor? It's saying delete these grades. So right now, the destructor, which is destroying gradebook, this object here, the blue one, it's destroying this pointer in heap, this array. This is what we said. And now you go back to main. So the program will continue. And now you go back to main, and main has an object OOP, which has a pointer grades, which is pointing to this address where we have nothing. And no one told grades, no one told this pointer, hey, you had an address. We are sorry, at that address, there is nothing because we just destroyed it. And when you have a pointer, which is different than null, and is pointing to an address here, and you don't have space there, and you try to delete that space again. Why do we try to delete this space again? What's happening after do something? Main terminates. You see, this is the end main. Now, when the main function terminates, what's happening with its stack? It's destroyed. What do we have on the main function stack? We have the OOP object. So who's destroying the OOP object? The same destructor. What the destructor is trying to do, delete these grades. This pointer is different than null, but here we already deleted this space when the gradebook copy has been destroyed. And you can't delete same address twice. And that's why the application is crashing. That's why you see the pop-up, because we are actually trying to delete the same space twice. Now, when you have this case, when you have a pointer pointing to an address in heap, which has already been deleted by you, this pointer is called a dangling pointer. Okay, so at this point, when you have this image, this pointer grades here from gradebook, it's called a dangling pointer. So this is the dangling pointer. And generally, when you have a dangling pointer and you try to delete it again, you see that pop up, dangling pointer. So a dangling pointer is a pointer which has an address which is already deleted. You have this address here, but the space is not yours anymore because some seconds before you said, let's delete that space. So this is the dangling pointer. Remember that. Okay, so who's to blame? So should we blame the destructor? No, because we had the next a course last week on this topic, and we understood that the destructors are okay because we removed the memory leaks. So the destructor is just trying to do his job. Can we check if a pointer is a dangling pointer? No. So how do you check? We don't have a function to ask the operating system, hey, I have this address. Is it ours? Can I delete it? No. So you can't check a dangling pointer, unfortunately, not in C++. So we can't check to avoid this delete. So let's find the root, the cause of this issue. So who's to be blamed? You see, when we call do something, because this method asked for a copy of an object, it created this blue box and it got the copy of OOP. But you see, the thing that is wrong in this image, if you check the picture, the only thing which is wrong here, which is actually creating this context, is this line. You see it? This pointer points to the same address. Because when this copy is destroyed, we are deleting this space here, which is also pointed by the official grades pointer from OOP. So this is actually what's wrong in this picture, that you have two objects with the same address. Okay, so how do we remove this? How do we create a new object which should point to a different address? Because you see, when we create a copy, we should have for that copy a different address. So who's to be blamed? Not this function, not the destructor. But the only reason is that special constructor which we get by default, and that's called the class copy constructor. And the class copy constructor has this definition. So even if you don't define it, you get it for free. And the class copy constructor, you see, is always called to create copies for your objects. So how the class copy constructor looks like? It's still a constructor, you see, it still has this name constructor. But the fact that makes him different and the fact that it's called copy is because it's receiving objects in order to create a new one. So here, it will receive a gradebook object. Okay, now, if you define the copy constructor like this, the compiler will tell you that the copy constructor should never receive an object by value. Why not by value? Because this is the copy constructor. Remember, when we have written do something, we received an object by value, gradebook, gradebook. So the constructor responsible for copying the OOP object to create a copy on the do something stack was the copy constructor. So what do we understand from this? That every time you have a function which receives an object by value, the copy constructor will be called to create a copy of the receiving value, which is OOP. So the copy constructor is called automatically every time you have a function which receives an object by value. So this is another function, right? It's the copy constructor, but it's another function. And this function receives an object by value. So this function will call the copy constructor to create a copy of that object. But wait a minute, this is actually the copy constructor. So if if we are allowed to write this, here you will have infinite recursion. Why infinite recursion? Because this is the copy constructor which will call itself again and again to create that copy. So how can we pass an object? How can we pass something to a function without actually giving the value of that thing, of that object? So can we send something to functions without actually sending the value itself? But
yes, using reference
to send the address.
Exactly. So you see, pointers, if you use pointers, you don't need the copy constructor. So that's why the copy constructor is always defined with an asterisk, or you can use also the reference from C++. You can't have both because it's the same thing. Remember, the reference is actually the asterisk hidden by the C++ compiler. So this is actually the copy constructor. You can define it both ways. Now, the official way of defining the copy constructor, because we talked today about const, is this. Why? Because you see, here, this is the value from which you take values, and this is the object that you want to create. So this is the copy of the object you receive here. So generally, the sense of sending values is from object into this. So why I write const here? Because I don't want to do this trivial mistake. Object course name equals this course name. This will be a mistake. Because you see, you change the value of this object that you receive from something which you want to create. So the sense of the flow of information is from object into this. So this is the copy you want to create. So that's why I write const here, okay, in order to prevent me from writing this mistake. So generally here we will do this. This course name, or you can use the, remember, you can use the initialization list. Again, it's still a constructor. So here I can say course name of object.course name. So I take the value from this object here. So I don't need to write this course name equals course name. Okay. And this is where the default copy constructor is doing that mistake. Don't write this. Grades equals grades. Equals object.grades. Because if you write this, this is exactly what the default copy constructor is creating for us. Okay, this is the shallow copy. This is where the copy will have the same address as the initial object. So don't do this. Okay, don't do the shallow copy. Don't go into the light. Okay, don't do the shallow copy. Okay, so what do we need to do to create a new array? So these grades, and now we fix the previous image, equals new int of object dot number of grades. Okay, for int I at 0, I less than object number of grades, I plus plus. I think here memcopy will do the work. These grades at index I equals object dot grades at index I. Don't forget to initialize the number of grades. So this number of grades equals object dot number of grades. Okay, so I have now the copy constructor. You see, I didn't change anything here in main. Okay, I didn't touch do something or other value functions. So build, rebuild. Okay, debug start without debugging, and here it is. Okay, everything it's okay, because now the function do something will receive a copy, but that copy has its own pointer. So when the do something function terminates, the gradebook object from its stack is destroyed by the same constructor. We don't create memory leaks, but now it's destroying the copy of that array. So each object now, each copy will have its own address. So it's safe to delete that when that object is destroyed. Now, why the copy constructor is dangerous? Let me show you. Let's add here, add the end line calling copy constructor. And this will be the proof that it's called. So if I build, rebuild, okay, debug start without debugging, you see calling the copy constructor right before something. So it's called automatically. Now, when the copy constructor is also called, so this is one case. Every time you have a function which will receive an object by value, the copy constructor is called automatically. If you don't have it, you are in trouble. So that's why you should define it. Okay. Now, what your colleague said, if I do this void do something, let's copy it. But this time I will do something with pointer, if you ask a pointer, that's a different story. You don't need the copy constructor. Why? Because you just get the address. So here you don't need the copy constructor. So you see, pointers are actually safer than objects. Okay, now when the copy constructor is also called, when a function is returning an object by value. For example, here you have this function, create init gradebook. Okay, string name. And here you have this function, string name. And let's say here you just say gradebook of name, and you just return it. Return gradebook. So again, here, if I call this init gradebook here, it doesn't matter if I don't get the value. So let's take another course, data structures, DS, data structures, whatever. Okay, if I will run this example, build, rebuild, and run it, you will see it again, calling the copy constructor. You see it after something. So all the functions which return an object by value, if you have here, will call the copy constructor. And the last case, when you actually want the copy constructor, so here you actually want it, okay? You want to create a copy of OOP. So how do you call the copy constructor? Calling the copy constructor, you do this. Gradebook OOP copy equals OOP. So when you create a new object and you write equals another object, this is again the copy constructor. So build, rebuild, start without debugging, and here is the message again. So we have three copy constructors. When we call do something, when we have called the init, which returns, and this is me creating a copy of OOP. Gradebook OOP copy equals object-oriented programming. Okay, so let's end with the rule. If you have at least one dynamic field, a pointer, which is managing addresses in heap in your class, when you define the class, you should define the destructor and the copy constructor are mandatory. So even if no one will ask you to do that, please do it. Because without the destructor, you'll generate memory leaks. And without the copy constructor, it's just a trap, okay? When you will reach one of these points, and we will reach this next week with operators, because operators will receive objects, it's just a disaster to happen, okay? At some point, you'll create a dangling pointer, because that's the way of the default copy constructor to do shallow copy, and then it will crash, okay? So copy constructors and destructors are mandatory for your classes. And remember, if you have a set, or every time you change that address, try not to do shallow copy and try to avoid memory leaks, okay? If you have at least one dynamic field in your class. Okay, so this is the story with how can we define a class, copy constructors, constant attributes, static attributes, and next week we will have a full day over operators.